Our last unit of study is going to be about solving quadratics. So far we have done vocabulary of quadratics. We have factored quadratics in the polynomials unit. And we have talked about the domain and range of it. And we've matched it up for its equations, okay? But today we're going to look about solving equations. Now we've actually kind of touched on how to solve a quadratic. We just didn't really emphasize it because it's within these vocabulary words that you see on the top of your paper. You see the roots, zeros, x-intercepts, solutions. What have I always called those words? What is the name? Yeah, the rocks. So everybody write down the rocks right now. R-O-X-S, but then draw a line through it to help us remember it's the x-axis. The rocks hold all the solutions because the last word right here is S for solutions. We're also going to talk about how that relates to its factors. And remember, factors are the parentheses things. After you do the X puzzle and solve it, you find the factors. So right now, on this graph that you can see on your screen, what are the rocks? On the x-axis is -2 and 1. We're going to write the rocks next to these so that we remember that it's the roots, the zeros, the x-intercepts, and the solutions. But that's super important for us because all of those vocabulary words mean the same thing. So the roots, which is another name for the solution of an equation, is -2 and 1. The zeros of that graph are -2 and 1. The x-intercepts are the same spot, but remember, because they're intercepts, I'm going to have to give it like a coordinate, -2, 0, and 1, 0. And then this part right here is the most important part of today. The last word of rocks is solutions. So if I was asking you to solve a quadratic, all I have to have you do is find the zeros. Find the x-intercepts. Those are the solutions.
That's the solution.
That's the solution. So remember when we did like regular equations here, let me show you for a second. Let's say we did regular equations, 3x minus 1 equal to 5. How would you solve for x? Plus 1 on both sides. You'd have 3x equal to 6. What would you do next? Divide by 3, divide by 3. So you'd get x is equal to 2. That is called the solution. That's the solution to a linear equation. The solution to a quadratic equation is found by finding the rocks. These are both the same vocabulary word, but this one is for linear, and this is for quadratic. So we can solve it, and we're going to solve them by hand after we work on solving them by graphing after spring break. But right now we're going to work on solving by looking at this graph. Now what's cool too is if I solve this quadratic, I can also immediately know its factor. The linear factors, the things in parentheses, if I were to like sit down and do an X puzzle for this, I'm just going to give it to you right now and I want you to figure out how this is true. The linear factors for this quadratic are x plus 2 and x minus 1. Who can make a connection here? How did I figure that out? Just by looking at the zeros or the solutions. Yes, Anicia?
Like the X puzzle sign.
Okay, I didn't do an X puzzle though. I just know this based on this information. You're right, if I did an X puzzle, I'd get this. But if I just look at this information, I can immediately tell you this. How is that possible? Yeah, but what about it specifically? Look at these numbers and then look at these numbers.
You switched the sign?
Oh, I switched the sign. That's literally it. Factors have the opposite sign for the rocks. So the factors have the opposite sign of the value of the rocks. That is a property of factors and zeros that we need to talk about. Factors and solutions. So if you look down at this table right here, if I tell you that the roots, zeros, x-intercepts, and solutions were -3, what's the factor? What plus 3?
X plus 3.
X plus 3. Yeah, just literally the opposite sign. If the factor is x minus 5, what's the solution?
5.
5, the opposite sign. If the solution is -9, what's the factor? If the solution is 0, what's the factor? X plus 0. What is x plus 0, though?
X minus. No.
X plus nothing.
It's just one.
Okay, let me back this up. If I say 5 plus 0, what would you give me?
5.
So x plus 0 is? What?
Just X.
If 5 plus 0 is 5, how is x plus 0 0? Okay, no. Last little bit here. This one's a little bit tricky, so let's talk about it for a second. If the factor is 2x plus 1, what's the solution?
Half. So half.
Ooh, super close.
Is it 1 half? 2 over 1.
Okay, I like what you're thinking. So here's what David's thinking. He said, hey, at the end of factoring, we always swung that number forward. So, like, let me put it back. So I have a half because I took that 2 and I swung it back underneath the denominator. But it's positive 1/2 in the factor, so the solution is negative 1/2. That's the relationship between solutions, or x-intercepts, or rocks, and the factors. And knowing this relationship is going to allow us to solve quadratics very easily. Okay, pause for a second. Okay, so if we consider the function f of x equal to x squared minus 6x minus 16, on your paper, if you look, my handwriting is already printed on there. What did I do to that function?
You did the, what's it called again?
Ooh, I did an x puzzle to factor it. Very good. I like those words. So I did 1s on the bottom, negative 16 on top, negative 6 on the bottom. I made a list of the numbers that multiply to what? 16, which is 1 times 16, 2 times 8, and 4 times 4. Am I going to add or subtract those numbers?
Subtract.
Why subtract?
Because there's a negative.
Okay, because there's a negative at the top. Cool. So I'm going to subtract 1 minus 16 is negative 15, 2 minus 8, and 4 minus 4. Which one of those rows works? 8. Or negative 8 and 2. Okay, so then I did this. I said, okay, well, those equal to 2 and negative 8. So bleep, bleep. And we've got my factors of, bless you, x plus 2 and x minus 8. Now that's cool. So my factors for this are x plus 2 and x minus 8. That's what I got as the factors. Like the factors, remember, are the parentheses. Anytime you see the word factor, we're talking about the parentheses things, the things that multiply to make the quadratic. Well, if those are the factors, I could tell you right now what the zeros are. What are the zeros?
Negative 2 and 8.
How did you get negative 2 and 8?
Because before you put them into like the factors,
Uh-huh.
you have to switch the sign.
Yeah, the factors and zeros are just opposite signs. And if those are the zeros, what are the x-intercepts? Negative, I heard it, negative 2 comma 0 and 8 comma 0. My friends, this little graph right here next to all that work is the graph of f of x. What do you notice about the zeros of this function?
Touching the x-intercept.
At specifically what values?
Negative 1 and 8.
Negative 2 and 8. I did not need to do all the work that I printed on your paper for you, because I can look at a graph of it and I can find the solutions, which means I know the factors. Okay, so what I want you to do is, instead of every time needing to factor to solve this, I want you to graph to solve it. Those places where it crosses the x-axis, that's going to be the solutions.
But there's no graph in the episode.
If there's no graph, you have a graphing calculator that you can graph it.
Do we just type
But you're right. If you didn't have a graphing calculator, for some reason technology dies, yes, you'd have to factor it.
So you just put f of x, basically?
Yeah, if I were going to do this, if the graph wasn't provided for me, I could type this into Desmos with the f of x. Like, you can, that's just the name of the function. You can type that in. It's going to pull up this picture, and so I'm going to be able to see the parabola and then find the rocks. Does that make sense?
Yes.
Okay, cool. So there's plenty of ways we can do this problem. I want you to solve it by graphing. Yes?
Yeah.
Crispo, I think you had another question.
So you just put like the whole place and even that?
Yes. And you can just see where it crosses. Okay, cool. So that's what we're going to do for these practice problems. I didn't give you enough space to factor because I don't want you to. I want you to find me the zeros, which, remember, the zeros are the rocks. And I want I want you to find me the factors. Okay, what should you do first?
Type the equation into decimal.
Let's graph the equation. Very good. I'll give you a second. So I see a bunch of us have it, and what I want you to do on your notes, so you remember how you did this when you look back at your notes, I want you to sketch this. So here's my x and y axis. Where does yours cross the x-axis? -2 and 10. Okay, you don't have to give me very many points, but I want you to give me -2 and 10, and then I want you to draw the parabola. Is this a happy or a sad parabola?
Sad.
It's a happy? It's a smiley face parabola? Ooh, look how wonky my parabola is. Ew. Okay, so we know that that's what the parabola looks like. These numbers that you find, these are the rocks words. So this is going to help us answer the multiple choice part of this question that says the zeros are blank and blank. Which one should I choose?
A.
C.
Wait. The ones are opposite.
C.
The zeros, remember, are exactly what you see there. The zeros are exactly there. The factors are the opposites.
The opposite is whenever you put it into factor.
So the factors, which is the parenthesis part, is x plus 2 and x minus 10. The factors are the opposites. The rocks are exactly what you see. The factors are the opposites. The rocks are exactly what you see. Yes?
Yes.
Do you think y'all could do the second example?
Yeah.
Absolutely you can. Okay, I want you to do this next one. Go sideways. You're still going to find me the zeros, the rocks, and the factors, which is the parentheses, for g of x. I want you to sketch it on your paper as well. Just a good little sketch. All right, so if I were to draw this parabola, oops, wrong color. Here's my x and y axis. Where did your parabola cross the x-axis?
-12 and 12.
Okay, I'm just going to sketch those numbers on my paper because I want to know what it looked like. Was this a happy or a sad parabola?
Happy.
Happy, so it's a positive parabola. Ooh, I'm just going to draw that again because that was so horrible. Much better. Okay, there's my positive parabola, which means the zeros are at where?
Right there.
Okay, not helpful to say right there and just point across the room. Where? D, at 12 and -12, because those zeros are the rocks. We just want to know where it crosses the x-axis, which means that the factors are x plus 12 and x minus 12. What questions do I have? I need one question before I move on today. Thank you for those questions. Let's go to the third question. What? I said question too many times just now. Again, so, the question part says the same thing. It says, what are the zeros and factors of h of x equal to -x squared minus 4x plus 21? I'm going to let you answer. We have our x and y axis. Where does it cross the x-axis? -7 and 3. Does everyone agree?
Absolutely.
Is this a happy or a sad parabola? It's a sad parabola. Wah, wah. But that's okay. We still know the rocks are exactly where the rocks always are. It's where it crosses the x-axis. So we're looking for the answer choice with -7 and 3. And we want to make the factored form x plus 7, x minus 3, the opposite. Now here's something else about this one. You said that this was a sad parabola.
Yes.
Does anyone know what makes an equation create a sad parabola?
No. Wait, what?
How does an equation make it sad? What's different maybe? Let's do it this way. What's different? Ooh, the negative where?
At the
In the
beginning.
wait, no, right?
At the beginning.
Yeah.
The negative at the very beginning. Did y'all see this negative right here?
Yeah.
That negative in the beginning needs to be in your answer because it makes it a sad parabola. If there's no negative, that means it's a happy parabola, and we need it to be sad. So give my answer a little negative right there so we can have a sad parabola. We're going to talk more about why that happens after spring break. Let's do this fourth challenge question. You got it. Again, what are the zeros? That's the rocks. And factors, that's the parentheses, of f of x equal to 3x squared plus 7x plus 2. Okay, let's talk about this one. We've got our x and y axis. Where does this one cross the x-axis?
-2 and -0.333.
Okay, I'm going to write down exactly what you said. At -2 and at -0.333. Is this a happy or a sad parabola?
Sad.
It's happy, so it should have a plus sign at the beginning or a positive sign at the beginning. Now, my problem My answer choices are all fractions, and Desmos gave me a decimal. But guys, we need to start recognizing this decimal. What is this decimal?
1/3.
We need to know that. 0.3 repeated is 1/3. So this is negative 1/3. If you didn't know that, it's pretty obvious from the answer choices that it's 1/3. Like, it literally can't be anything else. But because this is true, which option am I going to pick for my roots, zeros, x-intercepts, and solutions? A is right. Now, if I want the factored form, there's a couple things we're going to need to do. This is going to be x plus 2. And I'm going to do it wrong at first. I want you to fix it. X plus 1/3.
Oh.
That's wrong.
Okay,
Very good. We have to swing this forward. So this is not going to be x plus 1/3. It's actually going to be 3x plus 1. We don't have fractions in my factors. So in factored form, there is no fractions. We swing it forward. But your zeros can be fractions. Okay, before we leave this page, I need one person to ask a question about these problems. Yes, sir. I got a really good question now. We're going to hear it. So if this was an answer choice, this is also the exact same thing. So I don't want you to be afraid if they write it in a separate order. The order of the factors themselves does not matter. It can be in any order because it's just multiplication and we can multiply in any order. Is that cool? Do we accept? Yeah, okay. Let's go to the last page. This last page is kind of like a shift for a second. This is like part 2 of the lesson. We're going to be doing what's called simplifying square roots. So my question to you is, what the heck is a square root? What does it look like?
The factor, like the same number.
Oh, squares are multiplied by the same number. So if you square root something and it's a perfect square, it should be the same number. What does this shape look like for a square root?
Isn't it like the it looks
check
like
mark?
the division?
It's like a
but it's
check mark
check
division. Exactly. That is a square root. I need everybody to write that at the top of the paper. That's what a square root looks like. It's called a square root because there's an index of 2 right here, but it's invisible.
It looks like someone they were living and then they just went.
It looks. Wow, I've literally never heard that before. He says it kind of looks like a flat line where it was like the heart rate monitor. Okay, my questions for you though is if you were going to hyphenate or shorten the word square root, what letters do you think are the most important? Choose 4 of them.
X and Y.
No, in just this word, square root, how would you shorten it? S,
Q.
Q, R, T. That is the computer version of square root. On your Desmos right now, I want you to type SQRT. Look what happens when you type SQRT. It changes to a square root. That is the computer code for square root. If you don't think you're going to remember that,
Oh my lord,
on
you're a
the
wizard.
on the keyboard for Desmos, there's also a square root button, but I think it's kind of fun to program it in there. So SQRT for square root changes it to a square root.
Is that the only like program thing there is, or is there more?
There's more, but we're not going to worry about it right now. Pi, P-I. Yeah. Okay, all right. Now we're all over the place. Okay, and before we really start talking about square roots, I want us to make a chart of perfect squares. So right now we're going to do x and f of x equal to x squared. And all that means is I want you to square the number in the first column. So what is 1 squared?
1.
What is 2 squared?
4.41.
What? What is 3 squared? What is 4 squared?
16,
5 squared?
25,
6 squared?
36,
7 squared?
49,
49. 8 squared?
64,
Wow, Christian just like, all right. 9 squared?
81,
81. Everyone should know this one. What's 10 squared? 100.
102,
What's 11 squared?
136, 121.
Okay, at this point, I think we're going to get to numbers we don't know. So go ahead and use your calculator. What is 12 squared? 144. What's 13 squared?
That's where I'll stop.
We got our 12. No.
169.
169. What's 14 squared?
That's big where I stop.
196.
196. And 15 is 225. Very nice. That's your
I get
table.
the all of them.
All day today we'll have this chart available, but these are perfect square numbers that we should pretty much remember. If not, at least up to 12, if not 15. Okay?
How am I supposed to remember all that?
You just memorize it. Like, memorizing is like important. You just,
That's why you have a brain, my
I don't
guy.
even know my own phone number.
that is
That's why you can't
terrifying.
remember
You need to memorize those sort of things. Do you really not?
No.
Okay, we're gonna have a test where Alex just has to memorize his phone number and everybody fails if he doesn't remember it.
Oh, great. That's fine.
All
Vas
right.
a ver, vas a ver
Okay,
si falla.
I'm just kidding. Just kidding. Okay.
No, María.
So what we're going to be doing today is using square roots and this chart of square roots to simplify square roots. The process is here for you. The process that you're going to do to simplify something like square root of 48 is to create one of those T-charts, just like we did when we were factoring. Once we're done with that T-chart, we're going to look for the biggest number in this list, this T-chart, that is a perfect square. The biggest number that's a perfect square is 16. Look, that's on my list. Okay, so then I'm going to take this row and write it instead of 48. So I'd say square root of 48 is the same as 16 times 3, because that's this row. And then I can split it. What? How do I know that 16 times 3 is 48? You have to make this table. This is like the X puzzle table. After I figure out what row of my table works, you split apart at the multiplication sign. So you have square root of 16 and square root of 3. But we know that the square root of 16 is 4. Right? Square root of 16 is 4. So this is 4 square root of 3. But what we've done is we've created an equivalent expression. What does the word equivalent mean?
The same.
So right now, I want you in your Desmos to type in on one row square root of 48, and on the other row 4 times the square root of 3. It's going to give you a decimal approximation for both of these. And you're just going to check and make sure that you didn't change the value of this number.
7.
So SQRT 48 and 4 SQRT 3.
That's 7.
So when you type this into your Desmos, do those decimal approximations equal the same thing?
Yes.
Yeah, it's like 6.9 something, right? This says 6.9 and this says 6.9. That's how we know we got this question right. So we should not miss these questions.
I know. I got it. Te entiendo.
Okay, last little piece of information before we get to our practice problems. Sometimes the question will look like this, where there's a number in front of the square root already. No big deal. All you do is multiply it by that number at the very end before you get to your final answer. So don't panic when you see a number in front of the radical, in front of the square root. Okay, let's do a practice problem together. We're going to write an expression that is equivalent to square root of 80. First of all, we see the word equivalent. We should get really happy because we know we're not going to miss this question.
Yeah.
We're going to take the square root of 80, which means I want to make a T-chart for the number 80.
I don't know that.
How do we make these T-charts? Can someone walk me through the steps?
Like the X factor.
1 times 80. So you start with the lowest number that will multiply to make 80. What about 2? 2 times 40. What about 3?
No.
No? How about 4?
20.
How about 5?
60.
No. Isn't it like 18?
15, 13.
No, 18.
13.
No,
15.
What?
No.
Guys, y'all have a whole calculator.
It's 16.
It's 16.
Wait.
How about 6?
Yeah. No, not
Not 6. How about 7?
No.
How about 8?
10.
Okay. How about 9?
No.
And then the next number would be 10. But I've already talked about 10. So I'm good. I don't have to do 10 again. All right. We need to look at these lists. What's the largest perfect square on this list?
4 times 20.
What?
20 is not on that list of perfect squares.
Oh, it's 6, 5 and 4.
Okay. The list of perfect squares is the chart you just filled out. What's the biggest number that's on that chart?
16.
16. So we're going to use the row with 5 and 16. We know that the square root of 80 is going to be exactly the same as the square root of 16 times 5. Where did I get this from again? The chart. We just made a T-chart for 80. 16 times 5 is 80, so I'm good to go. Then I just break this apart. This is going to be square root of 16 times square root of 5. But what is the square root of 16? 4. So this is just going to be 4 square root of 5. And we think that this is equivalent to square root of 80. But before we move on, we're going to check this in the calculator in your Desmos.
Yes.
So please do that. I need to see everybody check it. SQRT 80, 4, SQRT 5.
I feel my school right.
Okay, I'm hearing kind of around the room that I just need to walk through this question one more time. So without writing anything down, just look up at the board and listen. We started with the square root of 80. So I made a list of the things that multiply to 80. You guys help me out with this part. Do we know how to make a list here? Okay. After that, what I did was I found the largest number that's on the perfect squares list. 16 is a perfect square. 4 is also a perfect square, but 16 is bigger, so I'm going to go with 16. This row, let me circle it. This, bless you, this row is going to go inside the square root. 16 and 5. At that point, I can break apart the square root at the multiplication sign and make 2 separate square roots. Square root of 16, square root of 5. Well, the square root of 16 is 4. That's a fact. We know this. So I can just change that to a 4, and then I have 4 square root of 5, and then I'm done. Do I have any other questions after I walk through that one more time?
I have a question.
Yes, ma'am.
How'd you know 16 was the biggest one?
Ooh, that's a really good question. You can consult your brain calculator, or you can look back up at this list we just made of perfect squares. On this list, the biggest number that's on my list is 16, and its square root is 4. Okay, we're going to try another one. Are you ready?
No.
Yes.
Do you want to try a medium or a hard one?
Hard one.
We're going to do both, but do you want the medium one first or the hard one first?
Hard one.
We're going to go with this one.
Yeah.
Number 3, which is write an expression that is equivalent to. So we're simplifying this radical. What number are you going to make your list for? 5 or 27? 27. Okay, go. Okay, I'm going to start walking through this one, so if you're stuck, you can look. But if you're going, don't stop.
How do you get this?
Yes. Oh, it's
Yep.
so it's this one.
Have we gotten this far? The list for 27 is 1 times 27 and 3 times 9. What's the biggest perfect square on that list?
3 times 9.
9 is the biggest perfect square, so that means I'm going to make my radical 3 times 9. But then I can break them apart. I can have 5 square root of 9 times the square root of 3. I just wrote them in a different order. That's okay. I can do that. It's multiplication. What is the square root of 9?
3.
3. So I'm doing 5 times 3 times the square root of 3. What's 5 times 3?
15.
So I think that this is 15 square root of 3, but before I go, I'm going to make sure that these are equivalent by doing what?
Multiply.
We're going to check it in the calculator.
Oh, we have to put that 5 in the.
Yes, remember, if there's a 5 in the front, you can't just let it float away. It's a part of the number. Include the 5 at the end. It just gets multiplied in. No big deal. If we get the same decimal approximation in Desmos or in one of those yellow calculators, you've got this question correct. No reason to miss it. Okay, if we go up to number 2, which we're going to do together, it's the same prompt. It says write an expression that is equivalent to square root of 192. So I'm just going to make a list for 192. This list is a little long, so make sure you leave yourself room to do it. We take 192 and we divide it by 1. Comes out to a whole number. That's on my list. 1 times 192. How about 2?
96.
How about 3?
64.
How about 4?
8.
8.
How about 5?
32.
5?
Wait. Oh, no. I'm on 6.
5 doesn't go? Okay, 6 times
That's 2.
7?
I don't know.
8?
24.
9?
That's rough stuff.
Does 9 go?
I don't know that's rough stuff.
No.
How about 10?
No.
How about 11?
No.
How about 12?
16.
about 13?
No,
14?
no,
15?
no.
And 16 is already on my list, so I don't have to check anymore after that. Okay. Phew, that was a long list. It's okay, we got it. Now I want you to look at all of these numbers. What's the biggest number that's a perfect square here?
Yeah.
64 is the biggest. 16 is on there, but it's not the biggest anymore. We need the biggest perfect square, which means this is the row that I'm going to use. I'm going to say square root of 192 is equal to the square root of 64 times 3. Because 64 times 3 is 192. Then I'm going to break these apart. This will be square root of 64 times square root of 3. And what is the square root of 64? 8. So this is 8 square root of 3, I think.
Yes.
How do I make sure that that's correct? Check it in your calculator. I need everybody to check in the calculator. I'm human. I make mistakes too. All right, if we start working on number 4, like I asked, thank you for those of you who did it. We make a T-chart of what number?
125.
125. This one's not too bad. The list is 100 or 1 times 125, and what else? 5 times 25. Anything else?
No.
No.
75?
2 times, no, not 75. Yeah, I almost believed you for a second. So that's the whole list. What's the biggest perfect square on that list? 25, 25. So that means that we're going to take that number and we're going to put it into the square root. We have square root of 25 times 5. You could put 5 times 25. That's the same thing. But if I break this apart, this is going to be 2 times the square root of 25 times the square root of 5. And what is the square root of 25?
5.
So we're doing 2 times 5
10.
times square root of 5. So that is, yep, 10 square root of 5. We think,
Yes, my.
but before we leave this question, we're going to make sure
Let me get that home.
that this is correct. We have to make sure it's correct. This is a guaranteed correct answer anytime I ask you one of these questions. SQRT is square root.
Yes.
We got paper.
Yes.